That is a resonance arrow. It is not an equilibrium arrow. So what does that create? Anybody? Oh, sorry. One more. Okay, let's do that first. Then I'll come back. Yes. So what's the outcome of this?
There's a.
Should the skeleton change? Should the skeleton change? No.
No.
Agreed? The sigma skeleton does not change in resonance. The sigma bond arrangements do not change when resonance happens. We good?
Mm-hmm.
Okay. How many hydrogens on this carbon?
2.
How many on that? How about this?
1.
How about that?
2.
The atoms do not change when resonance happens. Those are the two things that do not change between resonance structures. So please make a note. Resonance structures will have the same sigma skeleton and the same positions and numbers of atoms. That doesn't change. The only thing that changes is the pi electrons. The only things that are moving are the electrons in those unhybridized p orbitals. That's it. It's very important. You cannot change atoms, you cannot change the skeleton. You can only change the positions of the pi electrons in the unhybridized p orbitals. With me?
Yep.
Yes, what am I missing?
The other.
The charge.
Where and what? Exactly. Good. Where and what?
Negative charge.
Where?
At cetane.
So which carbon will become negative? The one that got electrons.
Mm-hmm.
I got electrons, I'm rich. Where's the positive? If I lose electrons, I'm poor. So who left? Who lost? That guy. Exactly. The only change that exists between resonance structures, or rather the only difference that exists between resonance structures, is positioning of the electrons in p orbitals. The sigma skeleton does not change. The positions of atoms do not change. Okay, so these are resonance structures. Do either structure exist? No, they don't. What exists? And what do we call that? Hybrid. Right? Resonance structures do not exist. What exists is the hybrid. So how do we draw the hybrid? A mixture, so to speak, of these two structures. So here's what I do. I keep my skeleton the same because skeleton doesn't change. Now, was there delocalization between these three atoms? Did these three atoms participate in resonance? 1, 2, 3.
Yeah.
So, how about the other one? Was that also part of resonance?
Yep.
That means my electrons are delocalized. They are spread over all of these 4 atoms. Right?
Mm-hmm.
Now the charges. Where are the charges? What are the charges?
Positive on the left. and
Careful.
negative.
Slow down. What is the mixture? What is the middle ground? Mixture may not be the right word. If I'm one resonance structure, Carter is the other resonance structure, what's in the middle is the hybrid. Right?
Mm-hmm.
This carbon, did it have a charge?
No.
0, right? But now it has +1. What's the middle of 0 and +1? Sure, but again, the idea is not all resonance structures are equally stable. So maybe it's not exactly half of a plus, maybe it's something in between. So it's not a full positive, it's not a full 0, it's something in between.
Yep.
What about this carbon? Did it change charges?
No.
How about the next carbon? Did it change charges? Okay, then how about the 4th one? It was 0 first and -1 now. So what does the hybrid have?
Partial negative.
That is the hybrid. So hybrid is kind of a combination. It's kind of the middle of the different resonance structures. Does that make sense, everybody?
Mm-hmm.
Yeah, Okay.